Hello, my name is Alfonso Landaverde, and I'm just going to be doing the little tech demo for today. So, excuse if my mouse wanders. I've got the tech demo on the other screen, like the assignment, but let's just get into it. So, then also I have this here because while I am competent, I'm not brilliant. So, I kind of have my work here already, just to double check it if I get it, or just to ensure that I'm not leading anyone astray in the video. So our first task is to graph the line 111t plus 1000. So that is just r of t, which is what we'll do. So we'll just have x to be equal to 1 times t plus 10, which is just t plus 10. And then the other two are just 1t's plus 0. So I'm just going to put t's in. And then, boom, we get a line. It's really far away though, which is odd. But it's fine because I know that line works. So now we want to graph the plane 2x plus y minus 2z. And to do that, we will just use a function z equals fxy. So we'll just go ahead and plug in our numbers really easily for this one. We just set it equal to z. So if it's 2x minus y minus 2z equals 2, then we'll just do 2 minus 2x minus y because we subtract everything to the other side. And then we divide by -2 to get z by itself. And then when we draw it, boom, we get the plane. So now we have that plane, we can do the cylinder. So the cylinder is also simple. It just requires an implicit surface. And I'm going to just plug in the equation, which is x squared plus y squared equals 3. And then bam, we get an equation for it. And if we check right here, the plane doesn't go all the way through the cylinder. Oh wait, yeah, it does. That's just a little visual thing. That's weird. On this side, it didn't show it. Well, I guess there is going to be that little sink there. You get the point. Um, so now we've graphed the cylinder using the implicit one because it just allows us to easily plug in the equation of the cylinder. But now we have the hard part, which is graph the ellipse in the intersection of two surfaces. Demonstrate that your graph is correct by showing it both with and without the plane and cylinder surface visible. So, we need math, which I have appropriately put right here, but we have to parameterize this function so that we can put it into a space curve because we're looking for the thing. So we have our cylinder and we know that the conic section, I don't know if that's the right word, but the intersection, the disk that we will get is an ellipse. It's an elliptical disk of intersection between this plane and the cylinder. So, since the cylinder's equation is x squared plus y squared equals 3, we're able to do square root 3's in front of our cosine and sines, which is the parameterized x squared and y squared. So we have square root 3's in front. And then we just have our cos of t for x, and then our sine of t for y. And then z is a little bit trickier, and don't mind me referencing this. It is a big mess of numbers, but it's essentially we take our 2 square root 3 cosine t, and we add it with our sine square root 3, or our sine t square root 3, and then we subtract 2. So basically, we're just plugging those into the formula, instead of so let's see. You have 2 square root 3 cosine, and that's because you have 2x, and then plus square root 3 sine t, which is just y, because you're able to substitute the values in, and then you have minus 2. So then we just do that. We plug it in. So we have 2 square root 3 cosine t plus we plug in y, which is just square root 3 sine t, and then minus 2. I'm missing a parenthesis. Fine. Okay, let me see. Two square root 3 cos t plus square root 3 sine t minus 2. Ooh, there we go. Oh, great. I messed it up. I am back. I forgot the over 2. So now, boom, it lines up with it like it's supposed to. And we can make this a bit better by making our cylinder a bit taller. So we'll do it from, I don't know, -5 to 5. And boom, as you can see, that cylinder exactly matches the intersection point. So now I need to demonstrate that the graph ellipse is correct by showing it both with and without the plane and cylinder surfaces visible. So we're able to check it using the math, which is just because we set the two equations equal to each other and plugged them in and made them related systems and they're consistent systems, we're able to know that this is the cylinder or elliptical or ellipse that uh, intersects the cylinder and the plane. That's where they intersect. That's the surface created from the intersection. And we're able to show it with the graph because look at it, it works. Okay, thank you.